All right, this is worksheet number 2 continued. So this is still part of worksheet 2, just the second page. We're continuing to talk about the 4 categories of reactions. So we've already talked about composition reactions and decomposition reactions. Now we are going to talk about single replacement reactions. So as the name would suggest, this is a reaction where a single element takes the place of another element that is in a compound. So in a single replacement reaction, in your reactants, you always have a single element. So in this case, magnesium, and a compound, something made of 2 parts. So our silver nitrate, made of silver and nitrate, 2 parts, making it a compound. So we have magnesium. Sorry for my handwriting. So there's magnesium, and then there is silver nitrate. And if you look over on the product side, you may be able to notice that on the product side, now instead of it being the silver bonding with the nitrate, it's the magnesium bonding with the nitrate. And instead of it being the magnesium all on its own, it's the silver all on its own. So what's happened is the magnesium has come in and taken the place of the silver. Right, so now magnesium is with nitrate, and silver effectively has gotten kicked out of its spot, and so now it's all alone. So we end up with magnesium, nitrate, and silver. Even if you just compare the names of the reactants versus the names of the products, you can kind of see the flip-flop there. Now, one thing that I have to point out, and this is a really common mistake here. When the magnesium, the single element, goes to replace something in the compound, it can only replace something that has the same type of charge that it has. In other words, if you look up magnesium on the periodic table, you'll see it's got a positive charge, +2 as it turns out. So when it goes to replace part of this silver nitrate, it can only jump in and take the place of the silver, because the silver also has a positive charge. If you look it up on the periodic table, it's +1. The nitrate has a minus charge. So the magnesium could never take the place of the nitrate. If you did that, you'd end up over on the product side with Ag, Mg. A positive and a positive. 2 positives would never bond together. Remember, like things repel each other. It's like trying to put 2 north ends of a magnet together. It's just not going to happen. You can't get these 2 positive things together. So that cannot happen. Okay, so you got to be careful with that. So in this case, the element that was replaced was the Ag. It got kicked out all by itself. And the element that did the replacing was Mg. And so it's important that they both have the same charge, either both positive or both negative. In this case, they were both positive. All right, so if we go down to the double replacement reaction, right? In a double replacement reaction, kind of like it says, you're going to have 2 compounds, 2 doubles, right? So here we've got magnesium chloride that's made of magnesium and chlorine. That's what makes it a compound or a double. And we have silver nitrate made of silver and nitrate. So I'll write this in for the reactants. Magnesium chloride and silver nitrate. Okay, so what's going to happen in this case is that you're going to identify the first element in each compound, so in this case magnesium, silver, and they're going to swap positions. They're going to flip-flop. So the silver comes over to bind with the chlorine, and the magnesium goes over to bond with the nitrate, and that's what you end up with. So we have magnesium nitrate and silver chloride. All right, so when you get to class, you are going to finish filling in the blanks that I did not fill in for the examples, and you are also going to answer the 6 questions at the bottom that summarize sort of the big takeaway messages from this worksheet.